this next section, we're talking about parts of similar triangles. So two separate triangles, and we're looking at the parts based on three different areas, okay? So if these two triangles are similar, so we're starting with the information that we know these guys are similar to each other. So if they are, then we can say corresponding parts are also similar. So these are my altitudes. So if these are similar, I can say that BD, the altitude of BD, is going to be proportional to the altitude of FH. I am going to set that equal to the length of a side. I can say AB. Now, of course, these aren't congruent, but these are going to be proportional. So I can also say that AB is proportional to EF. I can also say that BC is proportional to FG. It doesn't matter which side of the triangle. So when you look at this, think, okay, altitudes, my altitudes are proportional, and then the side that's corresponding with that triangle is also proportional, okay? That's altitude. And it's very similar for angle bisectors. So the angle bisect, if these are similar, then QS is proportional to UW, and this side length QP is proportional to the corresponding similar side of UT, okay? So that's angle bisectors. Medians, and remember the job of these guys. The median's job is to split this segment in half, right? So if these guys are similar, now I can say that my median, HJ, is proportional to the median of LN, and this side length, GH, is going to be proportional to KL. And I can also say that it's proportional to HI, which is proportional to LM. You know, that's fine too. It doesn't matter which side of the triangle. So that's if I know triangles are similar, this is what I can say. So let's take a look at how we would solve lengths of triangles. Okay. Let's do 1 and 3 here. And let's look at what we got. So do remember, the biggest factor here is this Big Daddy statement. Look, these triangles are not corresponding to each other. They're not in the position to correspond. So I have to look at my Big Daddy statement to see which guy is proportional to the other guy. So if I'm solving for x, I know this is a median because it's cutting this segment in half. So I can say that x is proportional to 15. And now look, I have two different sides I can use. So I can say 16, but what is 16 proportional to? Who is TS proportional to? TS is proportional to DE, and DE has the length of 20, okay? So you really have to follow along with that Big Daddy statement. Now I can cross multiply, and I get 20x equals 240, divide by 20, and then x, of course, equals 12. Okay, so that's that one. Let's look at number 3. Number 3, we're working with angle bisectors. Okay, angle bisectors, we know that they're similar to each other. So I know this angle bisector of 32 is going to be proportional to this angle bisector of 24. Now, I've got to go back. So this top piece is representing the large triangle. This bottom is representing the small. And if I want to put my language to the side so I don't mess up, I can. So on the large, we're comparing this angle bisector of 32 to the small angle bisector of 24. Now we're going to compare the large triangle side length of 38, but who am I comparing AC to? Well, AC is proportional to EF, so I look over here and EF is represented by X. So that's how I'm setting my proportion equal to each other. So when I cross multiply, I get 32X equals 38 times 38 times 24 is 912. And then when I divide both sides by 32, then I'm going to get 28.5. Okay? And you can always go back, does it make sense? Well, this guy needs to be bigger than my angle bisector, and it needs to be, of course, smaller than 38. So I can go back and quickly look at that picture to make sure it's matching my statement. All right, let's flip that over and look at, and again, you're going to set this, you're going to set number 5 up the same way. All right, so let's take a look at what happens when you have one triangle and you've got an angle bisector in there. Well, this is called the triangle angle bisector theorem. Now, I want you to notice, we're coming up with more theorems, so we're probably going to have more proofs. So, look at what this says. It says an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. So what does that mean? It means that if AD is my angle bisector, it is setting the opposite sides. AD is now going to be proportional to DC, and I'm going to set that equal to AB and BC. Okay? So, set the opposite side into proportional lengths. Notice I'm going from left to right. So, AD over DC. Now, I still need to go from left, AB, to the right side, so AB over CB. Okay? So, let's look at how this plays out. So, here's my angle bisector, and it's telling me KM represents an angle bisector. So, there's my angle bisector. So, I know my proportion is going to be this segment length is going to be proportional to this segment length. And if I start on the left-hand side, 12 is going to be proportional to 18. So there's my proportion. I cross multiply. 12x equals 48 times 18. Actually, that's 4.8. 4.8 times 18 is going to be 86.4. And when I divide both sides by 12, I'm going to get x equals 7.2. And does that make sense? Yeah, it's a little bit bigger than 4.7, but it's definitely smaller than 18. So we are making sense. Let's look at number 8. Here's my angle bisector. It's telling me that. Now that should be K right there. So KM is my angle bisector. Now I don't have this length, but I can find it. If I know that JL is 39 and JM is 15, I know that this guy is going to be 24. So now I can set my proportion 15 over 24 equals x over 36. And now when I cross multiply, I get 24x equals 36 times 15 is going to be 540. And when I divide both sides into 24, x then equals 22.5. Okay, so that's how we're setting those lengths, those guys proportional to each other. If you have questions, come and see me.